Welcome to episode 143 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So I will now run the random number generator. The random number generator has returned the coordinates of 23 hours, 5 minutes, 52.0 seconds right ascension, and negative 35 degrees, 51 minutes, 11 seconds declination. This episode's coordinates point to a star that goes by many names, including HD 217987 and Lacaille 9352, but for whatever reason, professional astronomers, at least in recent scientific papers, like to call it GJ887, where the G and the J refer to Wilhelm Gliese and Hartmut Jareis, two astronomers who listed this star in one of their many catalogs. GJ887 lies in the constellation of Pisces Austrinus, or the Southern Fish, which doesn't really have much of anything in common with the constellation Pisces in the zodiac, except that both seem connected to myths, albeit different myths, involving the Euphrates River. So first of all, GJ887 is a red dwarf with a mass of 0.49 times the mass of the Sun and a diameter of 0.47 times the diameter of the Sun. So GJ887 could sort of be thought of as half a Sun, except in volume, or surface temperature, I suppose. Also, the total amount of light emitted by the star is only 0.037 times the light emitted by the Sun, which is much less than 1/2. Anyway, GJ887 is very close to Earth. The distance to the star has been measured to the very precise value of 10.724 light-years, or 3.288 parsecs. This makes it the 12th closest star system to our own, and also means that I can definitely use my Star Wars sound effects. The star also has the very interesting distinction of being the brightest red dwarf in the sky as seen from Earth, which is a distinction akin to identifying the world's largest dachshund, or the world's longest inchworm. However, the star has a magnitude of about 7.4, which is a couple of magnitudes fainter than what can be seen without a telescope. If you want to see GJ887 using a telescope, I don't really have any good recommendations on how to find it, except to point at the star's coordinates. While GJ887 might sound interesting enough just for being a really close red dwarf, what is especially exciting about this star system is that, in 2020, a group of astronomers led by Sandra Jeffers published a paper announcing the discovery of 2 exoplanets orbiting the star. These planets were found by measuring the slight periodic Doppler shifting in the star's light caused by the gravitational tug of the exoplanets orbiting it. Both of these exoplanets have been described as super-Earths, which would sound like the type of place that Superman would come from, especially since Superman came from a planet with a red star, but which actually means that the planets are just rocky planets that are several times the mass of the Earth. The inner planet, designated GJ887b, has a mass of 4.2 times the mass of the Earth. It's positioned at a distance of 0.068 AU from the star, where 1 AU is the distance from the Earth to the Sun. It completes an orbit about once every 9.3 days, and it has an estimated average surface temperature of 193 degrees Celsius. For people looking for extraterrestrial life, this planet is a bit too warm, at least for something resembling life on Earth. The outer planet, designated GJ887c, is a bit more promising. It has a mass of 7.6 times the mass of the Earth, orbits GJ887 at a distance of 0.120 AU about once every 21.8 days, and has an estimated average surface temperature of 79 degrees Celsius. This would be a bit warm compared to the Earth, but I quite honestly suspect that the poles of the planet might be comparable to the Earth's surface in terms of temperature. It's also possible that the star system has a third exoplanet, which would be named GJ887d, but the existence of this exoplanet has not been confirmed yet. If it's real, it would have a mass of 8.3 times the Earth's mass and would orbit at a distance of 0.21 AU once every 50.7 days. This would definitely place the planet within the habitable zone of the star system, or the place where liquid water and Earth-like conditions are possible. So GJ887 actually looks like an awesome exoplanetary system. It has 2 confirmed and a potential third exoplanet. One of the confirmed exoplanets is at the edge of the habitable zone. The possible third exoplanet would be within the habitable zone, and as a bonus, the system is really close to Earth, making it possible to study the exoplanets in detail. It even initially looked like GJ887 was an unusually inactive red dwarf. Many other red dwarfs exhibit a lot of flaring, and these flares would tend to bake away the atmospheres of any exoplanets orbiting the stars. However, long-term monitoring of GJ887 in the visible part of the electromagnetic spectrum showed that its brightness varied very little, implying that it did not exhibit the type of flaring seen from other red dwarfs, which would make its exoplanets even more likely to harbor life. Unfortunately, relatively brief ultraviolet observations of GJ887 demonstrate that the star does exhibit a lot of flaring. The flares just aren't seen at visible wavelengths. This throws a wet, ultraviolet-colored blanket over the enthusiasm for identifying extraterrestrial life in the GJ887 system, but I still think it's worth studying the system in much more detail. The location on the Earth's surface corresponding to the position of GJ887 in the sky is about 175 kilometers northwest of Tristan da Cunha in the Atlantic Ocean, which is about halfway between the island and the mid-Atlantic ridge. It seems like it should be somehow possible to connect this location in the ocean between 2 places with volcanic activity to something involving flaring on the surface of GJ887, but I can't come up with anything that makes sense. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. And I have received some feedback since the last episode. First, Mark Frost wrote, "Hi George, thank you for your great podcast. I enjoyed every one of them. The information you share is fascinating, and I love the way you weave fun and humor into each episode. I'd like to request an episode, or several, on cosmic filaments and galactic walls. Thanks again for your amazing work." Well, finding an extragalactic filament is going to be a bit of a challenge for me. I truly select objects randomly, so it will take me a little bit of time before I land on something like a filament. However, the other challenge is that astronomers don't normally name or catalog these filaments in the first place, probably in part because they aren't gravitationally bound objects like groups and clusters of galaxies. Still, I'll keep an eye out for a situation where I get randomly generated coordinates that land inside one of these filamentary structures. Also on Facebook, TK Arispe, describing themselves as a fantasy and sci-fi writer, says, "Hi George, I just recently discovered this podcast and I'm really enjoying it. Definitely a fresh and unique spin on astronomy podcasts. Thank you so much for producing it, and I'm looking forward to more episodes to come." TK Arispe also commented on how they heard me on the Jodcast, the astronomy podcast from the Jodrell Bank Center for Astrophysics, which I also recommend listening to. Thanks for writing in, TK, and feel free to send in any questions you have about anything I talk about in my episodes. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Hendy, and the sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.